of a function. Now, zeros we may hear as other names, such as the x-intercept, the solution, or the root of a function. And what a zero is, it is when your function is crossing your x-axis. So here's our x-axis, and here's our graphed function, because there's two ways to solve for zeros, graphically and algebraically. Graphically, it's where my function crosses the x-axis, hence the word x-intercept. Here, my function crosses right here, my x-axis. So if I was to count that out, it would be at -1, -2, -3, -4, -5, -6. So I would say my solution, my root, my x-intercept, or my zero, x here, my solution set is at -1, 2, 3, 4, 5, -6. There is only one zero in this function, and it's at -6. Now, if I was to draw a different graph that maybe had multiple zeros, something that has some curves going through it like this, I would find my zeros the same way I just found the zeros in my first function. Here's my x-axis, and I locate where my function crosses the x-axis. And in this case, it crosses it 3 different times. So here, my solutions are at 0, -1, -2, -2, and then -3, -4, -5, -6, and -7. And I'll write it from least to greatest as how we write our other solution sets. So -7, -2, and 0. And this plays an important role when we're looking to write equations from graphs. So again, the zeros of a function, otherwise known as x-intercepts, solutions, or roots, are where my graph is going to cross the x-axis. Now, if I want to solve this algebraically, given these two functions, f of x equals 2x minus 4, and f of x equals 1/2 x plus 3, it is where I cross that x-axis. So it is where my f of x, or my y, is 0. So I'm going to plug 0 in for f of x, and then I will solve for x. So here, 0 equals 2x minus 4. So I'm going to solve my equation. I'm going to add 4 to each side. 4 equals 2x, divide by 2. 2 is x, or x is 2. So here, my solution set would be at 2. If I want to solve this function, again, I would just set my f of x equal to 0, because that is where I would be crossing my x-axis. 1/2 x plus 3. So here I'll subtract 3. -3 is 1/2 x. And then to get rid of my 1/2, I will multiply each side by the reciprocal, which is a 2. So I will have 2 times -3, -6 is x. 1/2 cancels out. So here my solution set is just -6. So graphically, if we're looking to solve, we're going to locate where my function crosses the x-axis. And that would be where my f of x, or if we want to call it y, is 0, because that's how you fall on the x-axis, when you're not even going we're not going up or down on the y or f of x axis. So algebraically, we set the equation equal to 0.